Alrighty, let's go up here. Go to my channel. Content, live, now I want to watch that so that I can see the chat. Good. Good. So I've got some more of these boards to assemble. So the iron is warmed up. Hopefully the audio is alright. So let's start off getting some flux onto our board. We can populate it. And over there, and a Q-tip. Yeah, I got an order for some more of these boards. So the idea is to get going with it, start getting them made. Start getting some. Wonder if we're having problems. I think the internet might not be the best. I just want to quickly warn a friend that I'm streaming. Bear with me for a moment. Sip of Coke, and then we'll start putting these components down, start soldering them. Then over there. Good. Tweezers. So these are op amps. Pull them out like that. Tidy that up later. start putting them down. What I'm going to do is go till about lunchtime. So the stream's going to be about an hour. Then I'm going to make lunch and go and relax a bit. And then we might carry on a bit later and you might join. Today's a public holiday here in South Africa. That's why I'm at home. And I've taken tomorrow off as well. So I've got 4 days where I can get this done. And possibly some projects. Some electronics, some software. If you guys have any, let's put this on a more secure surface. Maybe you want to put it in chat. Some suggestions what I could do based on what I've got available. So let's see, we need 2K2. Like so. Oh, the mic. This cam over here is working quite well. Good. Very good. Turn the board sideways. I think you guys can see through your magnifying glass quite nicely. One for me, one for you. And then the solder cam. And then I've got these 3D printed dishes in which I keep the ice and the resistors. There's only two values, it's a 2K2, sorry, a 2K and a 10K. Like so. Get these on. The iron is hot and bothered, ready for action. Let me just make a quick phone call. I want to let somebody else know that I'm streaming. Just a moment. Hi, it's Duncan. Oh, so you're going to join in? Well, you're welcome to type in chat. You're welcome to start a conversation. Right. Yes. Yeah, I'm going to go till 12 o'clock. Yeah. It's hard to say. Yeah. Well, anyhow, let me carry on, seeing as I'm live. You too, thanks. Cheers. Alrighty, you can get back to work. And you guys get to see what's involved in making this stuff. Alright, the components are down. So let's solder. Oops. It moved. Yeah, hello steady hands. I haven't had anything to eat yet. Guess that doesn't help. So I'll go for an hour. Then I shall definitely be thinking about some grub. Right, so I've got this side of the IC is down. Now we've got the resistors. Start with the one side. Keep my fingers out of this thing. It does quite a nice job at keeping the smoke out of my face. Before turn it, let's do the side of these resistors. Now, so I think today's Workers' Day or something like this here in South Africa. It's also the last good long weekend, pretty much for the rest of the year. So Easter time, there's a lot of public holidays here, and there's also a lot of leave that gets taken. It's probably not the most productive time of the year business wise. Turn the heat up a little bit to 400. This is a fairly fine tip that I'm using. So yeah, basically I only work 2 days this week, and the 3 weeks prior to that were 3-day weeks. So not the most productive time of the year, that's for sure. Right. Do those bins. Like so. Right. We need to do that resistor. Clean my iron. I've got some more IC pins to do on this side. Get the solder down onto the pad. Keep the iron down on the board. Then just let it flow. The spectacles that I'm wearing are I think ×1 magnification, and then I've got the lens as well, so I can see reasonably well what's going on. So now these clip into the 3D printed holder like that. So that's ready for the pins next that come from the bottom. Then they go for cleaning, and then they've got to be tested. Right, see if we can get a bit more caffeine and sugar into me. It's a little bit shaky. Down my chin. So it goes. Right. Some more flux. Try and do it from this angle so you guys can see what I'm doing. Now even at work we noticed that business has slowed down. Easter time is not the most productive month business wise, that's for sure. Had some drives actually, or 2 of them come in this week, They are being used on a wire drawing machine for copper wire, and that lubricant that they use on those draw benches for copper wire is some kind of water soluble lubricant. It gets into the air as a mist, and it then coats the internals of the drive, and it ends up looking like this black grease. And remarkably, it takes about 8 years for that stuff, whoops, to kill the drive. But it does. And then you still get asked the question, how can you fix this? Only 2 of the 4 drives are dead. The other 2 still power up. Can you clean them? Nope. There's no hope for that stuff, because that lubricant actually attacks the plastics, the boards, everything. Once it's in there, it's done for. And you're not talking small drives, you're talking 100,000 rand drives. And stuff is allowed to deteriorate. And then they complain that they haven't got money for new stuff. But they don't look after the stuff. See it all the time. Let's ignore the problem. Head in the sand. What I'm going to do is just get these op amps down before I put the resistors on. So they don't walk around. Like so. So I got pin 5 down. I knocked this cam, didn't I? Yes, I did. Sorry about that. So what we want is 2K over here. Then the 10K is I think we're going to have to look at ordering more of these components. There's enough for what I need to do this batch, but then we're going to be very low on components after that. Resistors and op amps. So I shall warn my customer that this needs to be done, because I'll get free issued with the components and I'll just do the assembly work and more for my time. And obviously the testing. and we looked at whether these things can be repaired if they've been damaged. And by the time you've dismounted these surface mount ICs, cleaned the board, got it level again, prepared it to put new components down, you've actually spent more than it costs to build a new one. So they're not serviceable items. That's doing alright. And the smoke is going nicely with the fan. Right. Let's turn that around. Start doing some of the other legs. Like so. Down. Looks like I've got my camera set up reasonably good. You guys can see quite nicely what I'm doing. Quite happy with that setup. This is probably not your general person's type of interest or subject matter. It's strictly for electronics people. So the average person is probably not going to be too entertained by watching me soldering SMD stuff, but that's okay. It has its place in the world. Alright, get this one done. Now if one's using solder paste without a stencil, which I don't have one of, and hot air, one gets bridges between these pins which one has to mop up with solder wick, and it's not productive. This is just the most easy, efficient and reliable way to get it done. Just got a small soldering iron. Put the components down, solder them. So there's a desk light, there's a desk light, there's a desk light, there's two buttons overhead, and then I've got three MR16s over here shining in this direction. So that's what we got for lighting, and there's two bulbs over there as well. Lots of light is good. So once when I set up and going with this, one can think of putting on some music and relax and just sit and work. This sort of thing can be therapeutic. Sort of a time to just relax or to reflect on things. Of course it earns one some pocket money. That's always a good thing. This Q-tip works quite nicely for putting the flux down. Not bad. I actually got some YouTube music that I could queue up. Let's do that. Here. Music. YouTube music. Ambient. What we want. Stop audio. And then on to the playlist. Okay, that should do. Sorry about the loud volume when I first started the music. This is my first time doing it. So we did learn what needs to be done and what not. Right. That's a 2K and then the 10Ks. Gee, time flies. These don't take long. And after doing a board, you notice it's 10 minutes later. It's been almost 25 minutes since I started the stream. Now let's get some more op amps. 1, 2, 3. I'll check something here. Alrighty. Let's put the op amps down. Bring them over here so I don't see their numbers. Try and deal with this tweezers getting stuck between the legs. So. Like so. And another one. This music that I'm playing was just some stuff that I downloaded from YouTube's source of or supply of royalty free music. So theoretically we shouldn't have any issues with playing it. It moved. Move it back. Right. This is a PC fan, by the way. They're nice and quiet. I've just got 12 volts hooked up to it. Then it just runs at full speed. Power consumption is 250 milliamps. Then it's just ditching it in that direction. Pins are down, let's do the resistors. One. So this one as well. Good. I think the rest of the world is probably working today. And it's night time. In places to the west and the east of here, so you're not likely to see viewers from anywhere other than sort of Central European time. the end done. I don't recognise his phone number. Spam, I thought so. And back to the task at hand. I had a solder bridge, but fortunately the flux helped me out there. Alright. Have a sip of my beverage. Good. Without this 3D printed holder, this certainly wouldn't work very well. I think they're all soldered. Set them aside. I'm going to get about 10 of these done. Then I'll carry on with more at the later stage, because I've got a total of 25 to do. But having done 10 will be a good start. So my last video, I should be talking more. I'll eventually get into this live streaming thing, become a bit more chatty, learn how to sort of just sit and speak my thoughts. But my last video was fiber optics between Arduinos, and that was an interesting video. So what I need to do is get hold of some real fiber optics and demonstrate the project with some real fiber optic stuff, because then it'll make sense to more people what I'm doing. Where you go? Don't run away, or pimp. Let's turn it that way. Oh, and about the flux problem, what I ended up doing is getting an ultrasonic cleaner in which I soak these boards for 10 minutes with the ultrasonic cleaner set to 40 degrees C, and the solvent is methylated spirits, and then after 10 minutes I start it and I run the ultrasonic for 10 minutes. Then I just rinse under tap water, and then it goes into the dryer at 65 degrees C for a few hours, and these boards all test fine. Now that I'm doing that, but I was however looking to get myself a water distiller if need be, to rinse the boards with distilled water. With tap water you've still got dissolved solids in them, and the problem with it, with that water mainly, is that it contains ions, which makes it conductive, which is the same problem with this stuff. You got ions that make it conductive. That's what you need to remove. So I seem to be getting away with my current process. It took me 2 days to get that down. Not a trivial matter. But I think it's sorted. So getting to the point where I'm getting the soldering done, this process of soldering, and then the cleaning process afterwards, and then the hey, Double Whiskey, good to see you there. Welcome, welcome, welcome. Thanks for joining in. What are you up to on this day? I know you're at home, so what are you up to? What's good, eh? Tell me all about it. Good to see you here. Thanks for joining in, and thanks for letting me know you're here, and thanks for making it this time. Always good to see you around. Now I'm going to bore you with watching soldering. Shame. Come on. There we go. Right. And setting up for this live stream, it's actually quite a bit of work, because you've got all the lighting to set up, you've got 3 cameras to set up, the green screen has to go up, the thumbnail has to be generated, you've got to set up the broadcasting software, and halfway through you think, well, some music would be nice. By the way, how does the music sound on your side? Is it too loud or too soft? Because I haven't checked. I don't have earphones on. I can't hear what you're hearing. Solar paste stencil. This is low component count. This is low volumes. You know, I'm going to be making changes to the process. Big changes. And I've already got something that works, you know. How much better is solder paste and a stencil going to work for me? Because the only thing that's going to benefit me at this stage is if I reduce the time. I don't have a quality problem, and I wouldn't say I've got a big time problem. So yes, a solar paste stencil will work. Oh good, thank you. But I don't really have a problem that I need to solve at this stage. And now that I've got something that works, making changes creates a concern of what problems am I now going to have. How do you like the camera setup? Are you happy with that? Let's have a look. That resistor is a little bit stiff. Let's fix that. That's better. So you haven't answered my question, Double Whiskey. What are you doing today? What are you not doing? Because I know you're watching my stream. So what are you supposed to be doing instead? Are you supposed to be working? I know you're always working. So do you actually have the day off? Alright. Let's smear it down. Oh. I thought so. Oh, thanks for the feedback on the camera angles. You have my permission to take the day off and watch my stream. Then thereafter, you get back to work. Right. Some more on that side. You have some boards to build. Don't we all? It never stops, does it? I guess you're busy with prototypes. And of course then you got to make software work for them. That's fun and games. Let's get this down. Yep, that's right. Yeah, the ultrasonic cleaner, that process works a treat. It's got to be a heated ultrasonic cleaner, so it needs to be a commercial grade machine that one uses. I haven't experimented with other settings. I found what worked and now I'm staying with it. Which was not a hard recipe to sort of get down. Hey, busy with production. How many boards do you have to assemble? Oh, now I can't ask you what it's for, which is fine. I have a suspicion anyway. Let me guess, your components are smaller than mine. So what I've done is I got rid of the scope here and I've got the laptop here. That's where I can see the chat. Put the laptop on top of the fireplace. The hands are starting to calm down a bit, which is making this easier. Quarter to 12. We'll see how we feel at 12 o'clock. It's not a hard rule that we have to stop at 12 o'clock. Over there a bit. Yeah, you can't see the mic, but it's absolutely right here. So that's why the audio with my voice should be good. And I've got the PC volume set fairly low, so there shouldn't be any echo. Because what you hear, the music that you're hearing is from the PC out. It's not from the mic. So that's hopefully not producing an echo. Just some chill music and watching a guy solder. That's how we roll. If these were very small components, then it would be a problem. Then I would have to use a stencil. Your smaller components are going to move around when you try and hand solder them. That is going to be a problem. So we are getting away with it because we've got fairly big resistors. But if they were smaller, like half that size, that would be a different story. Then this process wouldn't work. Then I'd have to use a stencil. And I'd have to cook the boards afterwards. Yeah. 603. 403. Yeah, that's a problem you got there. 403. Yeah. Like watching paint dry. Listening to music while you watch paint dry. That's funny. How's the wife doing? Is she doing alright? Yeah, I think what we're going to do, instead of calling it a time, I have to put some more flux down there. That caused the solder bridge. Yep, I'm going to have to work it up. Make 10 boards. And then it's time for some R&R, some food and some R&R. Ah, she's working, yeah? I've got customers who want their work done and got bills to pay, so we work. That's why we are sat here like this. Oh damn, there's another solder bridge. I'm not paying attention. Some flux. Let's get some wick. Ooh. And this is where it all goes wrong. Right, let's put that back there. Put that back. Right. Let's put the side cutters to that side. So stop knocking things around. That's it, fixed. Now I'm going to add a bit of solder back. Carefully. Right, that's those done. Yep, you got to see it live. Camera's falling over. I'm using MagBase over here on the 3D printed holder for the solder cam, and it's not the most stable thing. I need to buy another boom actually. Here I got a boom which works pretty well, and then that cam is close pegs to the shelf, so it's safe. But here we got a bit of a safety problem. But you know what, it's getting the job done. Let's get some more flux. Put it down. Now the thing about me live streaming and the concern about bots and spammers and so on in chat, being a small channel, I'm too small to attract those problems at this stage. You're the only one here so far, so we got this place to ourselves. It's like a little private conversation. What point? You're asking me a question. They must have a port number on it, but I can't tell you what it is so I'd have to remove this tip, but it's small, it's very small. Yeah, it's this is the station has a 2004 and the iron is a 1002. That's the iron that I'm using. Because the number is normally on the side of the thing, and this is a big tip, that's a 305, so that's probably that dimension over there. So that tip that I'm using is probably a 301. It's small. Yep, fly under the bot radar. When the channel gets big enough for bots to be a problem, then we'll deal with it. People often ask me whether I'm monetized. To be monetized, you need a minimum of 1,000 subscribers, and you need 4,000 watch hours a year. Now currently I've got over 3,000 subscribers, so that's sorted, but the watch time is only 800 hours a year, so the watch time is way short of requirements for monetization, and it's going to be that way for a while. And I'm not too concerned about the monetization because I have a day job, and therefore this channel is at this stage going to stay ad free, which for a lot of people is nice. I don't mind ads on channels where YouTubers are earning a living out of it. I believe they should get paid, and it's okay for the ads to be there for them to get paid and earn a living, because if they don't get paid, their channels don't exist. For me, that's a different story. This is a hobby, it's not an income. So we're keeping it like this, and it's good. So that's a little bit about what's going on with the channel. Yeah, I think it's a 301, because I think that end is about 1 millimeter in diameter. And the solder that I'm using that's 0.5 millimeter, it's 0.46 or something. I think it's basically the finest of the tips that you get for this iron before you start looking at something like going to a micro pencil. Those micro pencils are amazing, but they're for the very, very small stuff. Come on, resistor. do those. Also, these days you get heated tweezers with which you can do the soldering. They're also nice, but they're probably more suited to rework than production work. But for rework, they're amazing. The heated tweezers or the micro pencil? Right, how are we doing? We have 5 boards made and we're busy with the 6th one. Then we're going to make another 4 boards. And then it is time for some lunch and some R&R. It's 12 o'clock now. We're doing alright. Micro pencil. Okay, nice. Who's the manufacturer of the pencil? I know a lot of people like the Hecko stuff. To do this side. Right. Yeah, so once the next 4 boards are done, it's going to be lunchtime. Oh, no time, and then I'm afraid you have to go back to work. You. Or you can disobey me, do as you please. Then the 2006. The Magnum stuff works. I don't expect anything fancy from a soldering iron. Straighten that camera a bit. No, it must just work and give me the temperature I want, and I'm sure you feel the same. It looks like I've soldered all the pins. Put another one down. Give this a nice good coating. Like so. The nice thing about the Magnum stuff is the local availability, and we've been using this stuff for years. It's been around forever. And I feel that its value is at the right point. Now, it's not too cheap or too expensive. because we're a little bit isolated here in terms of choices for shopping when it comes to tools. You don't just decide to import some stuff and a week later it shows up. Don't work like that for us. Come on. Other way around. There's a good resistor. We will not tolerate resistor insubordinance on this channel. That's right. You do get nice stuff, but yes, you pay for it. You're absolutely right there. And yes, there isn't a requirement to use that equipment. We're not working with FPGAs and BGAs and that sort of stuff. Not one too many op amps out. Whoops. If you are doing repair work on BGA stuff, you absolutely have to have that equipment. Or you're doing production work on BGA stuff, that stuff is needed for rework, which you hopefully try and keep to a minimum, because rework is expensive. One should plan to never have to do rework. It's very, very expensive. Yeah, that camera's in the right place. I am using, I've forgotten the name. These magnifiers are just Rolson. That's the brand. Helping Hands. I'm just using them as magnifiers. What I've done is I've removed these parts of them, just using them as magnifiers for now. But those alligator clips for holding stuff to solder are very useful. And at the time I bought 2 of these, but I've only been using one. And I was trying to get this set up with that camera over here, and I could see this was going to be a big problem. So I unboxed that one and I set that camera up with its own lens, which I think has been a good idea. If you can't see the pins, you stay away. With or without these. Even with these you sometimes can't see the pins, then that's definitely stay away territory. I mean, a GPU's got 2,500 pins underneath it. You need microscopes to work on that stuff. And if pads have been ripped and you have to start putting down lugs masking, doing that sort of stuff. Oh boy, no, that's deep into specialist territory. I watch videos where people do the repair work on boards with those devices, and I'm like, that's nice. Glad it's your problem. Because not only are you dealing with a technically challenging process, but you're dealing with repairs from the public. You're dealing with the public. I think those are two evils properly combined there. I think that coping with that sort of stuff is expert level, and it's not me, I think. I mean, I'm a repair center admin, but it's industrial equipment. So there's a little bit of a difference there. Need to rotate that again. Do that side. Those are done. Oh, need to do that resistor. That's not gonna work. Done. Yeah, even if it's not BGAs, and some of these dip packages or the square packages, those pins are so close to one another. It's terrifying. No, thank you. And basically with that stuff you build the prototypes by hand, but after that they're touched by machines, not humans. The days of being able to solder leaded components onto a board with an iron that you bought from the hardware store, they're long gone for sure. Those are fond memories we have of assembling boards and kits and putting stuff together with leaded components. That's what got us into this trouble in the first place. That's why we're here. PJ, yes, you can only see the balls on the edge. Yes, you need X-ray. Yep. And guess what? You can't exactly go to the hardware store and buy yourself an X-ray machine to examine BGAs. that's deep into specialist territory. Examining BGAs or examining multi-layer boards. That's commercial work. That's not hobby level work. And it's not a repair center, you know, like gaming consoles and PCs and stuff like that type of work either. You know, when you do a reflow on a BGA in a repair center for consumer products, you do your best and pray. If it doesn't work, you do it again. Anyone resistor, please? One at a time. Got lots of flux for all of you. I've got flux and solder for everybody. One at a time. Now we need that op amp facing the right way. Would that be a large or a small animal doctor? Because you get two types. Clicky. I know what the resolution is on that X-ray equipment they use. They sort of examining bone structure and soft tissue. Probably not looking for detail down to a 10th or a 20th of a millimeter. I don't know what the resolution is on the machines that they use for looking at PC boards. Never looked into it. Don't know how that stuff works. Only heard about it. I know my employer has one at the R&D center overseas. Alright, you're a resistor, you behave yourselves. I don't want you walking around or becoming upstanding citizens. No tombstoning from you today. Stay down, be a good resistor. Same with your pimp. Hold your feet on the ground. Yeah, for household pets, they're able to x-ray something as big as a small wolf. But yeah, they're not going to be too happy if you show up with your donkey, that's for sure. They're very interesting machines, those PET X-rays, X-ray machines. Then you get the portable ones, which can basically do an A4 size X-ray. So the CCD inside that portable X-ray, the detector is basically the size of the area that you're imaging, and then right against it is a scintillator which emits the photons, and then your CCD picks up as an image. Very interesting stuff. I've got 2 more pins to do here. 2, 3, 4, 5, 6, 7, 8. We are getting there. We were planning to go for an hour. More like a 2-hour broadcast, which is fine. How's that looking? These parrot cams pretty much have fixed focus, but this Microsoft cam can focus up fairly close, which is why it's nice for the solar cam, the close-up cam, because I can manually focus that. You do it through the software. That is quite useful. Alright, we got 2 more to go and then we're done. 1, 2. Right, here we go. Exactly. Exactly, that's how it works. Your scintillator is basically a phosphor screen, as you correctly pointed out there. And then instead of exciting it with electrons, you use X-ray energy. So those would be gamma particles. The alpha or gamma, it's the one that's got the energy to go right through. Yeah, it must be alpha particles. It's one of the two. Alpha, beta, gamma. One of the two is the high energy one that goes straight through, and that's what you're using for X-ray imaging. Now, trying to stay away from stuff. Problem is that this reel is quite big. Okay, that lens has moved too much. Get some more of those. Deal with the packaging. Come on. One more. Come on. Thank you. Right, let's put a resistor down. So what I've done is this lid is marked, but also can't see too well on that one, but I've marked the bottom as well, so that one doesn't get these things confused too much. Try not to. Now, if you had lots of different resistor values, having lots of these dishes standing around would be a problem. But because you only got 2 of them, it's not an issue. But you wouldn't want 20 of these sitting around on your workbench, because it's going to get cluttered. And the chances of an avalanche of resistors that then has to be sorted becomes good, and a real threat, and a big danger, and a big problem. You don't want these things spraying around. That's a bad day. A very bad day. Here we go. If you ever watch Ben Krasno's stuff, Applied Science, I think his channel is, he did a couple of videos where he worked with portable X-ray sources and the imaging parts, and he had one open. Well, he had to resurrect it, and then he demonstrated how it worked and talked about it. That's where I learnt about that. Is from him. That guy is also a next level scientist. I mean, it just happens to have an electron microscope in his backyard. That type of scientist. Alright. Yeah, if you dropped a few thousand resistors on the floor, even a few hundred, I don't know how you're going to deal with that problem. I don't know what one does then, especially if they're not big ones which are numbering on them. Now these are still got numbers I can read, but the small ones that don't have numbers on them, yeah, don't know what you do. Right, let's do this pins on the other side. This one. Yeah, that's what I thought. Get the hoover out, just bin it. There's basically no cover recovering from that mess. Alright. Then is that one done. Down to the last one for now. Get them fluxed. The 8-pin socket, the pins that go over here, that's basically quite quick. What I do is I've got this jig, and then what I do is I set the pins in there, pop this board over like that, solder those, and then those are done. So that's not a biggie to do. And now I hand on the board, so I've got sticky fingers. And then these, I'll fit a lens cap over it when it's not in use. Alright, let's get back to the task at hand. Get this last board done for now. Starting to get hungry. So another 3 10Ks. Yeah, I'm getting back to that problem with the flux. I had it with one board where it caused a feedback loop and it sent the op amp into oscillation, and then as you cause the op amp to set fire to itself. No, it's not a good problem to have. Three. Right, put that over there. The op amps. These are Oppo 7s. They're instrumentation op amps. Set one down. Yeah. It's not good when the board you're testing begins to smoke. Mind you, we were testing one of those 464 amp drives yesterday and we couldn't find the diodes on the middle phase. And when we opened it up, there was a crater where the IGBT had been. Thousand amp IGBT lying there in pieces. It's less prevalent these days that the VSDs do destroy themselves in that fashion. The protection has got good, but it's not 100% guarantee that the groot ontploffing is not going to happen. Alrighty. Done. Once one gets into a rhythm with this, goes quite quickly, and basically by the time you finished with this job is when you found your rhythm. Starts off all shaky, towards the end you're getting good at it, and then the work's finished. Like a lot of things in life, eh? That one, and that one. Like so, that's all of that. Inspect it. Alright, those are ready for the rows of pins. They look like this. We use those pins. These ones, I just cut them to length and put them into the jig. So let me show you how it works. So what you do, take these, cut them to length like that, set it in there, set that aside, and then what we do, set that board over like that. Once you got the pins coming through the holes, it's quite easy. It goes quite quickly. You kind of make sure that they're pointing upwards and they're parallel. Don't need quite that much. Put a little bit of flux on. Then we solder them like that. Sorry, I only saw that message now. There's various layers of protection. There's current sensing, and then there's, so you got current sensing going out of the IGBT on the UVW phases, and then you also check the voltage drop across the collector to emitter that it happens within a specified time, a certain time, that it decays within it's quick, it needs to be nanoseconds. No, it's not that fast, it's microseconds. It's 1 or 2 microseconds. The IGBT's got to turn on, and that voltage across it has got to fall down to a few volts, you know. Now if you're drawing a lot of current across the IGBT, that voltage is going to be higher. Then you know you got a problem. So you turn the IGBT off again. Now you can have current flowing through your IGBT because it's going out, or you could have shoot through where one IGBT has failed or stayed on for some reason, and the top half of the bridge turns on. You get conduction through both transistors. That's generally when things get bad, and if the protection fails at that point where they both turn on, that's when an IGBT turns into dust. But generally that protection, where it looks for the voltage coming down as well as fast current sensing on the output, that's where you pick up problems on your load side, either on the cable or the motor, and either phase to phase or phase to earth and so on. And if you've got a lot of capacitance on the output of the drive, you can obviously have current flow as a result of that can trigger overcurrent errors as well. Then you start needing inductors. So that's a story with that. So they look at voltages and they look at current, and it is done very fast as well. Very, very, very fast. Just going to set that over there and put the lid back on this stuff so we don't have it drying out. So here we have that board. Let's see what it looks like. So it comes out looking like that. Alright. And that plugs into the amplifier, into the strain amp. Right, soldering iron's off. I think I can go get this flux off my hands and make myself some lunch. It's definitely time for it. We've got 10 boards done, 15 more to go, so that's what's involved with making these little boards. So what I'm going to do is put those there, far away from the edge of the table where they can get knocked, in a safe place. Yes, that's right. So it's basically active sensing protection. Yeah, that's right. The IGBTs can suffer degradation during that time where high current flows and the voltage is coming down but not fast enough. You get heating in it, and obviously with enough, that's the point at which it melts. But during that time where that a lot of energy dissipated in the junction, you do damage to it. So with repeated events, it's eventually over for it as well, and then your protection is not helping you out anymore. There can be issues with the gate driver circuits and the control circuits where things have gone wrong, and they intentionally turn both sides of the bridge on at the same time, and then obviously things get bad as well. So yeah, there's a whole lot of gate sensing and then collector to emitter voltage sensing going on, and then the current sensing as well, fast DC CTs on the output. So that's it. Alright, I'm going to go make some lunch. I'm going to end the stream. Thanks my friend for being here, and the others who have watched. I appreciate your time taken out of your day to be here and watch me do some soldering and talk about stuff. It's much appreciated. Have an awesome day further. We'll be talking soon. You'll see me around. Take care. Regards to all. And till next time. I'll try and give you a bit of warning next time that the stream's coming, if I can get myself organized. Alright. Cheers everybody.